Okay, let's start with the first problem. Now, first of all, remember I gave you that sheet with the squares on it that sort of gave you the order of how you want to do the problem? That's not a bad thing to have on hand because it's something that you can learn how to follow, and after you've done the problem several times, they should become second nature. Now, we have learned how to convert grams to moles and moles to grams, right? All right, so we know how to do that. You have to have the molar mass from the periodic table. Right. Now, your assignment a couple of days ago was to learn how to make a mole ratio by the balance equation, right?
I didn't get how to do that before.
Okay.
I didn't think that's a problem.
Okay. All right. Well, let's do. Well, first of all, one of some of the problems that you had in your textbook were vocabulary oriented. So when asked you for particles, you were supposed to say like formula units and atoms and molecules. And then when you got to the second part, then you were to interpret the balanced equation by how many moles you had. But if you didn't get that, that was okay. But we'll talk about when the rest of the class is here, we'll talk about the answers for those problems, okay? In order to be able to do your homework tonight, this is what you need to be able to do. And all it is putting what you've learned in certain order. For example, you learned how to do mole ratios, right? Am I right? Okay. And you learned how to convert from grams to moles. So all you have to do now is just put it all together in the correct order. And if you use that sheet that I gave you at the beginning of the year, that sheet should help you. Okay? So you'll notice here that there's a balanced equation, and for any stoichiometric problem, you have to have a balanced equation. So here we have 8 moles of iron, and we have 1 mole of sulfur. You notice that sulfur is an S8 though. And we end up making one product, and it's 8 moles of iron 2 sulfide. So if you get the amount of any element or compound in a balanced equation, you can figure out everything else. Okay? So this problem is asking you how much iron is needed to react with 16 grams of the sulfur. Now they're saying you have 16 grams. How much iron are you going to need to use all that 16 grams up? That's basically what it's asking you. So personally, I like to start out the question or the math problem with what am I trying to find. So I'm going to say question mark grams of iron. That's what I need to find. Now there are different types of stoichiometric problems. This one can be labeled, I guess you would say, mass to mass. You're starting at mass and you're ending at mass. And how do you know that? What mass of iron is needed to react with 16 grams? That's mass of sulfur. So that's a mass to mass problem. So you start with mass and you end with mass. You always have to convert mass to moles. So that's going to be our first step. The mass we have is 16 grams of sulfur. We're going to convert that to how many moles we have. That's 8 actually. So 1 mole of it. So you'd have to take the atomic number 32.1, that's sulfur's atomic mass, and multiply it by 8. And you end up getting 256.8 grams of it.
Why did you multiply by 8?
Because you'll notice in the formula it says S8. You have to use exactly what's in the balance equation. So there are 8 sulfurs. And that is one of the forms of the element sulfur, ends up bonding to 8 of them to make. So I took 32.1 and I multiplied by 8. All right. Now, since I am trying to find the relationship between this element, Fe, and this element, sulfur, that's the mole ratio I use. I'm not really concerned about the iron sulfide right now. So how many moles of sulfur is in that balanced equation? 1 mole. So 1 mole of the sulfur. And how many moles of iron? 8. Okay, so now we've converted the mass to moles. Then we use the mole ratio, because the ratio between how much of each you need is very important. And if it asks us how many moles do you need, then you'd be done. But it's asking you how much does it weigh? What is the mass?
How much is 8 moles of iron?
That's just the ratio. If you were to solve this problem right now, it would tell you how many moles of iron you need.
Should be 8.
Well, no, you don't necessarily need 8. You have to do the math of the whole problem. That's just the ratio from the balance equation. So now you have to figure out, well, how much does it weigh? So all you do now is convert the mass of iron to the moles of iron to grams. So how many moles of iron? 1 mole is how much? 55.8 grams.
Times 8, sorry.
We already did the times 8 in the problem.
Okay.
That's taken care of right here. Now, I have to admit that 70% of chemistry is this kind of problem. When you go to college, you're going to have a gazillion of these.
That sucks.
It's going to be on different types of, things that you need to calculate. This is just mass. Okay, so when you go to see if your problem's set up right, you should be able to cancel every unit except for grams of iron, because that's what you're trying to find. So you see here, grams of sulfur, that's canceled. Moles of sulfur is canceled. And moles of iron is canceled. The only unit you have left is grams of iron. Can you see that?
Yeah.
Okay. So my suggestion in multiplying and dividing is to do this. 16 times the numerator divided by the denominator times the numerator divided by the denominator times the numerator divided by the denominator. You do that order and you don't have to re-enter anything. Now, of course, if you have the number 1, you don't bother. So this problem, you have 16 divided by 256.8 times 8 times 55.8, and you're done.
So is it 27.8?
The answer is 27.8 grams. Correct. Don't you think that's relatively easy? I mean, initially, yeah. Okay. Do you have that little grid in front of you? That little square thing? I think that really helps. So let's try the next one doing that, okay? 27.8. I don't have any extra on me right now, but if you know of someone who can make a copy for you, that'd be great. I'll look to see.
So mass to mass, you're just going straight across here.
Yeah.
Then, if it's volume to mass, you go.
You still would go in the same order.
Just a different.
You're starting with a different quantity. All right. So let's try the next one. It says, in continuing this information, how many grams of iron 2 sulfide, would you actually make? So,
You just add the 2.
you could. No. Well, thinking about the fact that it is the,
Because we have both masses.
yes, if you were thinking about conservation of mass, you should be able to add those 2 and get the right answer. But let's say we didn't do the first problem. Let's say we didn't have that number. All right, let's just start that way, because you don't always have both. And what would be a good idea is to see if that answer matches the addition of those 2. That would be good, checking. Okay, so the question mark is, how many grams of iron 2 sulfide am I going to make? So a good way of checking is the quantity that I wanted to find the quantity that I actually found in the problem? And that's kind of a way of double checking too. Because I have question mark iron, and then my answer's grams of iron. So now my question mark is grams of iron 2 sulfide.
So is that you usually at 27.8?
You could, but for this particular practice, we're going to practice stoichiometric problems, so we're going to just pretend like we don't have that number right there. And we're going to start with 16 grams of sulfur again. And then, of course, we already had from the previous problem what a mole weighed, so we have to calculate that again. And it's 256.8 grams of S8. Now, what's the mole ratio we're going to use for this problem? We are comparing sulfur and iron sulfide, aren't we? Oh. Okay, so 1 mole, correct, of sulfur over 8 moles of FeS. Now the ratio is the same. The only difference is iron sulfide doesn't weigh the same as iron. So if we were to stop here, we would have how many moles of iron sulfide we make, but the question says, what's the mass
How
of
would
it?
you have how many moles?
Well, like if you cancel these units here, right? And you cancel these units here. Now, oh, I forgot to write the word mole. Your answer now is in the form of how many moles of iron sulfide.
Okay, yeah, I see.
But it's asking you how much does it weigh. So then the last step is, in that particular case, is always to figure out what 1 mole weighs. So 1 mole of iron 2 sulfide weighs 87.9 grams. I actually just added the mass of iron and added the mass of sulfur together. And it's only 1 sulfur. Okay.
Now you're ready.
So, and then this unit cancels too. So I'm going to take 16 divided by 256.8 times 8 times 87.9, and my answer comes out to be 43.8 grams.
And then if you add those together,
It should match up. 16.0, 27.8, 8, 3, 4. Sometimes with sig figs and rounding up and stuff, sometimes it might be a tenth off, but hopefully it shouldn't be. Now, does it make any sense? Is it starting to help a little bit? Okay. Now, you had to recognize what I think really helped is that this is a mass-to-mass problem, and so is this one, mass-to-mass. But let's look at the next problem, number 2. It says, given the quantity, or given the following equation, you have 2 moles of sodium chlorate, and it decomposes, and you get 2 moles of sodium chloride and 3 moles of oxygen. So now you're doing what?
moles to mass.
Moles to mass. So that first step you don't need, because that first step is converting mass to moles. We already have moles, so we actually don't need that first step. So we're going to start out with, first of all, how many grams of oxygen do we need? Since sodium chlorate was given in quantity of moles, that's where you start. So mass is not needed. So we have 12.00 moles of sodium chlorate. And what's the next step? Looking at your little grid thing, what would be the next step you would do? Mole ratio of the quantities that are in the problem. So you have sodium chlorate and you have oxygen. So those are the 2 things from the balance equation you're going to put into the mole ratio.
So on the bottom, 1 mole of 10.
Okay, look. These are your, yes, 2 moles of the sodium chlorate and 3 moles of the oxygen. Everybody see that? Because there's the 3 moles of oxygen and there's the 2 moles of the sodium chlorate. Now, that sodium chlorate is gone. And what's the next step? Moles to grams, because it's asking mass. So now you just change it to grams. So 32 grams of oxygen is a mole of it. And that's just from the periodic table. The only thing that you have, this is given in the problem. This is the mole ratio from the balance equation, and this is from the periodic table. So, you know, much of the information is on some sort of table, or you can find it somewhere. So we're going to take 12.00, multiply it by 3, divide it by 2, and multiply it by 32. And I forgot to cancel these units. So my answer came out to be, anybody get an answer?
32 times 18.
576 grams.
Really? I got some. Okay. 576. But the only problem is that this is 4 significant figures.
570.
I'm going to put a 0.0 here, because I need 4 sig figs. I can't make it 5,760. I can't put a 0 there because that's not the quantity it's close to. You know what I'm saying?
Well, the troublemakers are the juniors always talking. So.
I know. That one's moles to grams, so that's a good idea to just write that. Moles to grams. Or you could say moles to mass. All right. Anybody want to maybe attempt to tell us the order of how we would do the next one? First of all, what type of problem is it? Grams to grams or mass to mass. All right, so it's mass.
So you got the mass, then convert, and mole ratio, and convert.
Right. That's right. That's it. So, we're going to start. Okay, well, thank you very much. Okay, so what are we trying to find? Mass of what?
O2. Wait, how many grams? Oh, NaCl.
Okay, how many grams of NaCl? That's what we're trying to find. What are we starting with?
80.0 grams.
Right. You have to start. The only quantity that's in the problem is the grams of oxygen. So these, you see right here, sodium chloride and oxygen, those are in your mole ratio. Those two are going to be in your mole ratio because that's the relationship you're trying to figure out. Now the equation does have the sodium chlorate in it, but we don't care about that right now. So what would be our next step?
Convert to moles.
Okay, the mole ratio is not next. What's next is converting that mass to how many moles of oxygen that is. Okay, how would we write that?
1 mole O2 over however much.
32. You would have to take the mass of oxygen. You take the mass of oxygen from the periodic table and multiply it by 2.
In the mole ratio.
Okay, so what is the mole ratio? No. You're right that the mole ratio is a 3 of oxygen, but it doesn't go in the numerator.
1 mole.
It goes.
NaCl.
Okay, so we have 2 moles of NaCl.
Why 2? Because there's a 2.
Look, see the balance equation? There's 2 right there.
Oh, we're still doing it from up here.
Yeah, number 2 is still part B is still part of number 2. Right, and then 3 moles of oxygen in the bottom. And how do you know that? How do you know which one goes in the bottom, which one? You want them to cancel out. This one, the one you're starting with, you want to end up with, so it needs to be in the numerator. The oxygen is in the numerator here, so you want to get rid of it. So now we have sodium chloride in the numerator. Now what's the next step?
Convert to moles.
That's right. So you convert moles to grams. So 1 mole of sodium chloride weighs 58.6 grams. And you should be able to cancel all the units except the units you're trying to find. And that only unit that wasn't canceled is grams of NaCl. And look, grams of NaCl. So 80 divided by 32 times 2 divided by 3 times 58.6, voila, gives us anybody? Okay, so how many, you're right. So how many sig figs would we need because of the quantity given?
87.6.
Okay, look 1 digit over. Would it round that digit up? Okay, so what's the answer? Correct. That's it. So if we have 80 grams,
That's grams, right? Grams of
I'm sorry, I'll move it over. So if we have 80 grams of oxygen, we would make also 97.7 grams of sodium chloride. All right? Okay, and let's try 2 more, and then the problems on the back, I believe, or some of them are exactly the same as the front. I mean, like exactly. So try to do, like I think number 5 is exactly the same as the front. Try to see if you can do it without looking at the front. The very last one, though, is not the same. All right? So, okay. Number 3. What type of problem is number 3?